right, so we're going to get started here. If you're just joining us, we're going to get started here in a couple minutes, exactly as the clock turns noon. With me is Greg Nelson, and we'll do a more formal introduction shortly. My name is Frank Lavinia. I'm filling in for Mark Tabladillo, and we are doing something a little different today. It's going to be an interview-style format. Won't be any visuals other than our smiling faces. And so you just hold tight. We will get started. Hello, my name is Frank Lavinia. I'm filling in for Mark Tabladillo. I am a certified data scientist. I am currently working at Microsoft as a technical sales professional in the advanced analytics and artificial intelligence space. With me today is Greg Nelson. Greg Nelson is got a quite impressive of a bio, if I do say so. Founder and Chief Executive Officer of ThoughtWave, which is an analytics advisory firm. He's also an expert for the International Institute of Analytics, and adjunct faculty at Duke University's Fuqua School of Business. Hopefully I pronounced that right. And did I do good?
Yeah, it was close.
Close enough. You'll give us the real pronunciation, I'm sure. But Greg has done some interesting things. He's authored over 200 papers and publications, and is a regular speaker and keynote presenter at national and international events in both technology as well for private corporate events. He earned his bachelor's degree from the University of California at Santa Cruz in psychology, a master's in clinical informatics in Duke University, and has done PhD level work in social and cognitive psychology from the University of Georgia. Welcome, Greg. How you doing?
I'm good. Thanks for having me on today. It's a beautiful day in North Carolina.
Yeah, it's actually not freezing up here in Washington D.C., so I'm very happy about that. So I understand that you've done quite a lot of work, and it's interesting how you ended up in advanced analytics. But I understand you recently wrote a book. Can you tell us what writing a book's a lot of work? What motivated you to write a book?
Well, as my publisher will tell you, it's not the money. The book is entitled "The Analytics Lifecycle Toolkit," and I was really, for those of you who remember back to the late '80s when Ralph Kimball wrote his seminal work on the Data Warehouse Toolkit. It was really an homage to that, in the sense that I loved how he set out what are the best practice areas and what processes are involved, and outlined a number of best practices and subsystems, for example, for ETL. And what I wanted to do and what I saw was missing in the marketplace was a book that was, instead of conceptual or cookbook-like, and I saw two extremes in the marketplace, is I wanted something that really helped people understand the entire life cycle for analytics. So that was the primary reason.
Right. So you do how do you define data science in your book, and how that fits into this process? Because data science, obviously, it's a hot term.
Sure.
Kind of the, big data was the hot thing in the early 2010s, and now everyone can't stop talking about data science.
That's right.
What does it mean to you?
So it's an interesting question. I actually spend the bulk of the first chapter just sort of laying the foundation for a lot of the terms that we hear. And I resisted, in fact, using the word data science for many years, because I think words that don't help provide clarity to an environment only add to that confusion. So things like big data, data science, even cognitive computing and machine learning, and more generally AI, I think are sort of concepts that everybody feels like they need to know, but there's no common definition. And that's true of data science. I found especially true of the way I think about data science is it is a scientific discipline that covers all aspects regarding data, and that includes how do we ingest data, acquire it, transform it, process it, store it, and then use or make experience out of that data. And I differentiate that from the analytics lifecycle, which is, I think, a more of a business strategy around how do we use data for fact-based decision making. So they're complementary, and certainly data science relies on the fact that somebody is going to be able to do that work in the context of an analytics effort. So hopefully that makes sense.
That does make sense. One of the phrases that you've used in your book is this notion of a data champion.
Yeah.
What exactly does that mean? Do they get to, what is a data champion?
So several years ago, this was about 3 years ago, I went to a conference and I asked the audience member, how many of you are data scientists or aspire to be data scientists? And everybody in the room raised their hands. And I knew full well that the disciplines and the experience and the education were wide-ranging in that audience. And so instead of using terms like data scientists that necessarily introduce that ambiguity that I talked about, we have data engineers, we have statisticians, we have people who do visualizations and report writing. So there's a wide variety. Instead, what I wanted to do is actually come up with a term that helped democratize the sense of data so that it included not necessarily the supply side of analytics, but also the demand side. That is, people in the front lines using data for understanding their business, for changing something in the business. And so it just opened up the world of what does it mean to be data without necessarily getting into these wars about, well, I'm a data scientist. No, you're not, kind of conversation all the time.
Yeah, that's an interesting point. So when you mentioned business, obviously your book is very business centric. Have you encountered a sudden spike of interest since the Facebook revelations, where people are realizing, obviously there's a number of privacy concerns and things like that, and if there's interest, we'll go into that. But I mean, in terms of people realizing you can do all this with data, which I think for the layman, that's probably a revelation.
Yeah. Well, I have seen over the last few years with things like the quantified self, being able to use Fitbit data to track yourself, being able to get energy utilization data from smart devices, I think has been building, and that preponderance of data or information that are available at your fingertips necessarily translates to what data can I use in my organization, and why aren't we better at even getting simple things? If I can get my refrigerator to tell me energy consumption for a 3-month period, why can't I get a report on sales for last quarter? And that's fundamentally, I think, the expectation is that we are a consumer-driven, this concept of using data as a consumer needs to carry over to the business, and I think that's a good thing. I think there are two things that happened recently that make sort of the sensitivity to data privacy important. One is GDPR, which is the regulatory guidance, if you will, for doing business with folks in Europe, and as extended and gaining global adoption. And I think there's just that's a sensitivity to, in business, how do we make sure the data is right? How do we make sure it's secure, but also that it's protected and we're getting the right level of information? And I think both Facebook and Twitter and other ads, people who primarily work off of ads, have changed their business models in response to that. The second area that you talked about, which is this gaining crescendo of what I'll call this drumbeat of nuance in the back of our minds, or nuisance in the back of our minds around data for privacy and protection. Who has data on me? And I think there are people that just don't care. I think, for example, a lot of people regarding the Facebook stuff where they said, yeah, it's not like I'm posting anything, I'm not posting my social security. So what if they know my preferences? And then there's a lot of people who say, look, this is just too much. And that too much is a good thing, because I think our role in analytics should be to make sure that the data that we use, that we're being good stewards of that data and the analysis that are a result of that. So I think all of this is a good thing to create awareness in everyone's mind.
Yeah, I think that's really the key, is awareness, because I think if people share things and they know what happens to their data, that's better than happening kind of behind closed doors and under the table. If people do that with a certain amount of informed consent, I think that's a good thing.
It's some interesting. So I know one of the topics we want to cover today is around AI. And when I was doing some research for the book on chatbots and sort of preponderance of data, it made me wonder, and I won't disclose the name of the firm that was actually had a free chatbot service where you could write your own chatbots. And this was an example of a customer service. And while it was easy and intuitive, we know in artificial intelligence that the best thing you can do to help improve training is give it more data. And so this was I don't want to call it a ploy, but this was an attempt by that vendor to continue to get better by feeding it lots of data by creating what they called an open platform for creating service chatbots. And I dug through the acceptable use policies, privacy policies, and I kid you not, there were no less than 10 redirects on various policies and procedures, and I never got a straight answer. I finally reached out to their customer support service and says, who owns this data? And how is my data that I protect? For example, the business rules that I might encode about how one would answer a question. And it was fascinating to me. You know, the response was very open, which is good. And they said, no, we own it unless you opt out. I said, well, how do you opt out? And they couldn't even find it as a customer service. So it's one of those things that I think people just need to be aware of, that the more data we give, that you have to be responsible for its provenance, regardless of the form it may take later on in life.
Right. Well, I think that's a fair point, because who reads EULAs or terms of services? It's a very small percentage of the population. I think it would be interesting if there would be kind of a almost like a bullet list of this is what you're signing away. And I think that would give people pause. And I realize that there's with all the legalese, that may not be as simple as it sounds. But I think that would be, for me personally, I think that would be a step in the right direction in terms of transparency.
Well, and I do think there are some great examples of end user license or data use agreements that people sign that are very colloquial and very friendly and meant to be unarming. But I think to the extent that we can gain that clarity, I absolutely agree with you.
So our audience here in this group comes from a wide variety of backgrounds and experiences. Yeah. Obviously, now everyone wants to become a data scientist or whatever the term of the day is going to be. What is the difference between a data pipeline, which I think as a software engineer by training, that speaks to me, versus the analytics life cycle? What is that exactly? What's the difference?
Yeah, I distinguish between the data pipeline and the actual analytics life cycle in my book as a way to reflect on the different activities, because I think many people, when they consider sort of this broad definition of the discipline of data science, imagine everybody from statisticians and report writers to data engineers and people who are looking at real-time data feeds and trying to engineer those in a way that's useful. And I distinguish between them in the sense that the data pipeline is all of those activities that help to bring data for use in the organization. So it could be capturing real-time data, it could be traditional ETL kinds of activities or data engineering activities. But even in analytics, you'll hear, especially if you're familiar with Kaggle, the concept of feature engineering or data engineering for a problem set. And so in the analytics lifecycle, there will always be the opportunity to engineer features that were not stored in that native format, right? And so traditional data engineers, ETL programmers, data quality folks, data governance folks, MDM folks, sort of live in this world of the data pipeline where it feeds them the data that's going to be used in the analytics lifecycle. And the analytic lifecycle really takes on its own form. And I describe in the book 5 best practice areas where having a very solid foundation of that data helps them do their jobs. It becomes much more efficient.
So you mentioned the 5 best practices. Can you briefly describe them and what they are?
Sure. It's a little bit different than I think the terminology that there's lots of examples out there as to, what does the analytics lifecycle look like, and people call it even different things. I start with problem framing. That is, what is the problem? Who does it affect? Is this something we can actually solve? What is the impact of not solving it? And what's the best outcome we can hope to achieve? All of this goes into helping make sure that we get the problems that are important to the organization that will have the biggest impact. And that will come full circle when I talk about one of the later best practice areas. The second one is data sense making. Data sense making is, so they told us this was the problem, and now what data do we have to make sense of this? What are its distributions? What are its shapes? What's in these variables? What is missing values tell us about the environment in which we operate? That data sense making is really an attempt to bring all the data together. It's going to be helpful in solving a business problem. The third area is analytic product development, and I call it product development intentionally, as you'll see in a moment with the fifth best practice area. But the idea is that's when we'll do your typical team data science process or CRISP DM or whatever process you go through to actually develop the algorithm, specifically the implementation of that algorithm in a model. The fourth area is what I call results activation, which is what are we going to do with it? Is this going to be an operational process? Is this going to be a number that informs someone in a strategic planning session? What is it that we're going to do? And all the work up to this point should have been going to, this is an important enough problem to solve. We make sense. We've developed hypotheses about what might be going on, and we've gotten to this point where, okay, so what means we got to make a change, and so that necessarily includes operational change management and some of the other elements.
So sorry, go ahead.
Yeah, the fifth area is analytics product management, which is how do we ensure the effectiveness and efficiency of all those processes to yield high quality products coming out of our data science or analytics shops, whatever that might be. Even within a business or someone who wants to do that, it's things like, how do we know when an algorithm has exceeded its lifespan, that is, it's decayed over time? Or how do we ensure that the answers are right, that is, we implement quality assurance? And I view one of the key roles of the analytic product manager is to ensure value. And so there's necessarily that thing called value management. And, picking the right problems and solving them for the right customers is essential.
So in regards to the notion of having an analytics product management or manager role, is this something you've seen in the wild in your consulting work?
Yeah. It's interesting. We're seeing more and more of that. It used to be that we talked about this in terms of there's business and there's IT. And IT was the enemy and business was trying to do the job, and they were fighting with IT. And I like to sort of dismiss that dichotomy and instead talk about the demand side of analytics and the supply side of analytics. Supply side are those people who help solve problems. And if we view this as a service, and we do it, we develop data products like we would a real product like an Apple iPhone or a Microsoft gaming console, then we need to do that with empathy and all the other things that I talk about in the book regarding design thinking. Well, we can apply those to analytic data products, and it just shifts the mind. It's a change in mindset relative to what is it that we're trying to accomplish together as an organization.
Right. So have you seen this in your consulting work? Is this a bottom-up type grassroots level movement, or is this something that has to be driven from the top down, or some mixture of the two?
Yeah, I think it's both. I think a hybrid certainly makes sense here. Obviously, the leadership needs to understand why this is important to gain some clarity around what the value of it is, and I think that is necessarily people on the ground who know it and see the mistakes. Just talking about things like what is the cost of bad quality, or what is the cost of a bad decision, or data in our system. So that helps inform the overall strategy, but the strategy needs to really step up, and we're seeing this happen more and more with chief data officers, chief analytics officers. In fact, at one company I saw a vice president of analytics value management, which I was to see, because this idea of how do we manage the value in the analytic efforts that we go through, those are hugely important.
Right. Do you think that there's going to be companies that existing enterprises that they realize that their data has some kind of monetizable value, and it might change their business model? How receptive is the senior management to that type of change?
Well, I think anybody in a C-level role needs to understand that data is an enterprise asset, and we can treat it as one of two things. We can treat it as a distinct advantage for our company and use it selling it becomes a little bit of a challenge, but there are lots of companies that's exactly what they do, is they sell the intelligence of their data collection process. Other companies view that as a necessary operational mandate. And I just think those people will ultimately be the have-nots in this zero-sum game.
Right. That makes a lot of sense. Is it fair to say that it wasn't too long ago that data was treated as a byproduct, as exhaust, if you will, and now it's monetizable?
Yeah, I think a lot of people are nervous about exposing that monetization to an external constituency because of the fact that we still have data problems, right? And so just because we've been collecting data for 30 or 40 years and doing it well in some reasonably well-designed process, we still have data that's all over the place. My argument against sort of it being an all or nothing thing would be to treat it as, we have business class data, and that's data that is data that's highly curated, that's gone through extreme levels of quality assurance, in that we're using those not only for the most important strategic decisions for organizations, but that they're also being used as competitive advantage and even to monetize those. Then reflect on the fact that there are other types of data that we might have. So we talk about first class, business class, economy comfort, coach class, and cattle class. It seems like
steerage.
That's right. You too can ride in the cargo hold.
But I mean, realistically, though, data at scale the quality is going to vary wildly. And I think that's something that every practitioner kind of knows this. Is that still a stigma that data hygiene, if you will, is seen as an unattainable standard or unrealistic?
Yeah, I think I think there is the stigma that, somebody finds fault with some data piece of data somewhere in the system, that, we either say all the data is bad and throw out the baby with the bathwater, right, or that we don't release it to, in a sense, democratize it because we're concerned about what people might do. And I still hear that in organizations, no, we don't want users to actually do this because they may not make the right assumptions. And so I'm a huge fan of transparency, and the idea of data democracy means that let people crowdsource the issues and the solutions so that it's not all bottled up into what ends up being a bottleneck in organizations, that data pipeline.
Interesting. That makes a lot of sense. So Microsoft has grown significantly in the data and analytics space with their recent acquisitions, as well as the recent reshift of the company's direction. I say this as a Microsoft employee from 2011 to 2016, and now once again back. It seems like a very different company. What this year it seems like Microsoft's really focusing on the NLP, or natural language processing, the AI, the ML. What advice would you give the audience on where they should learn? Because they're coming from different backgrounds. They're coming longtime data professionals. One, what's your advice? And two, how did you find your way into this advanced analytics space?
Yeah. So you mentioned earlier in my bio that I teach at Duke University's Fuqua School of Business, and they have a program called the Master of Quantitative Methods, or Quantitative Management, excuse me. I've also taught at other universities, like NC State has an Institute for Advanced Analytics. And so this has been, I think, something really interesting that people can go into these programs. And it used to be that we could learn history and art and biology, and now we're learning more practical skills, which I think is what the employers are asking for, and hence a lot of these organizations, these universities have stepped up. We're also seeing a tremendous growth in Udemy and Coursera and other online programs for teaching various aspects of analytics, this entire analytics life cycle space, everything from storytelling to, how do you do reinforcement learning models. So there's always going to be something new to learn. I think about it in a couple of ways. One is, I think we learn for purpose or for potential. People who go off and get a master's degree are learning for potential. That is, I want to eventually do this job. I want to change my career, do a different role. Then there's learning for purpose. And I equate most of the MOOCs and Udemy's and Coursera and the online programs as being well positioned and suitable for learning for purpose. If I have to do something, I may start Googling around and look, or sorry, you guys have a search. Right?
Bing, yeah.
They might Bing around. And the answer to the question, that's, in my mind, that's a great example of learning for purpose, right? So we have to learn something. Let's go read up on it. Let's figure out what it is and learn enough to be able to do the task at hand. I think when it comes to enduring proficiencies in the analytics space, I would focus on really some of the skills that I don't know people are going to necessarily like or appreciate. One is develop your problem-solving skills. Developing your analytic thinking skills. I posed a question that was derived out of a book, and I apologize, I don't remember the book off the top of my head, but where somebody said, well, if you were to give an executive an impact analysis on the BP oil spill, how much oil would you say is coming out of that spill every day? And so many people, including engineers at BP and other organizations, would not estimate because they had no idea. And this author, the statistician, reflects on the fact that it's a pretty easy calculation, right? So we know how to measure the volume of a cylinder, and we try to understand what is the rate of change from that cylinder at the pipe flow, and we could come up with an approximate estimate. In the book, I give an example of the bat and ball problem, which I'll encourage people to Bing or read the book. But the idea is that people who can solve problems by thinking their way through what is the core expectation. So in the case of the BP oil spill, what is the general order of magnitude about how big of a problem this is? And notice that none of that reflects on the technologies in the space. The technologies will continue to grow and to evolve. And I say get good at three things. One is making sure you do problem-solving skills. Two, make sure you understand the business in which you operate extremely well, and then pick a niche in the data and analytics lifecycle that fits your interests, skills, and desires, and get to the top 1% of your industry in that particular area. And I'm sure you've seen that with your own career. Things that you're really good at, you're proud of, and your heads above everyone else when it comes to doing that well.
That is sound advice, that's for sure. So you mentioned statistics. Obviously, given your academic background, you have your bachelor's in psychology, which I understand there's a lot of reading and a lot of statistics and data gathering there. And then you have your master's in clinical informatics. One, would you say that your background in undergrad doing stats has helped you in this analytics space,
Yes.
as well as math? And then two, could you define what analytic informatics is?
Yeah, so absolutely. I think someone who has a good understanding of data but lacks the fundamental knowledge of statistics, things like distributions and inferences and how to draw samples and various tests for significance, I think fundamentally everybody in analytics should have a core set of knowledge. Now, do you need to be a theoretical statistician who knows how, for example, to compute a multinomial regression, multiple regression, multivariate kind of problem? And a lot of students come up to me and says, gosh, should I learn more stats or should I learn more math? And I said, yes, you should absolutely continue to learn. Now, is that at the expense of other things in your career, like understanding how to do problem solving, how to negotiate with people, how to gather requirements better? I think all of it's going to depend on your role. So number one, I think the work in cognitive psychology and my PhD level work, and as well as the background in undergraduate psych, absolutely laid the foundation for being able to be, I think, sufficiently productive in this field. And then your other question, clinical informatics. So informatics and analytics are often used interchangeably by, unfortunately, folks who don't necessarily know the difference. Informatics is the intersection of what I'll call data management for, in this case of electronic health record in the clinical context, it would be the management of that data and the use of that data. So for example, in a healthcare environment, you might use an electronic health record, manage its databases, manage all the records. And then informatics is how do we make sure that the workflows are ensuring the integrity that we find in the data so that people downstream who do analytics can actually do that well.
Interesting. And that, from what I understand through other people I've interviewed on the podcast and what I've read, that's really turning kind of the pharmaceutical and medical world upside down, isn't it? The informatics or bioinformatics?
Yeah, what's interesting, so there are lots of informatics. There's clinical informatics, medical informatics, bioinformatics, all relate to the management of data and the intersection of technology and data for those various fields. I think things in biopharma, and I spent a lot of years working in that field and continue to have clients in that space, is that the better you get at managing realistic data is a skill that will never leave you, regardless of what the context is. And so what we find in traditional biopharma, the sort of the real world evidence that we're seeing by people going out and doing observational research by getting data out of normal operational systems like electronic health records, that's new to biopharma. They've bought data, they've assembled data, but clinical trials data is very much a sort of a white room data collection process versus electronic health record. If you've ever seen a hospital, you'll know that every hospital you've ever seen is completely interrupt driven. And so how do we, that nurse or that physician who's doing the next thing, make sure that data gets in there well and right and justifiable, and they're not putting as much energy into interfacing with the computer as they should with a patient, right? So by definition, the data is not going to be as good as we might hope if somebody was there and that was their whole job to do data entry.
Interesting. You've also done PhD level work with social and cognitive psychology. Has that also helped you approach kind of the neural networks and how computers can learn? Is that as a parent to a young child, I can kind of see, my son will get things wrong, but I can understand how he came to the wrong conclusion. And I see the same thing with certain neural networks. Well, that's clearly wrong, but I get why you came to that conclusion. Is that?
Yeah. And that's why I see reinforcement learning is so critically important. You know, obviously one of the drawbacks of things like neural networks in general is their explainability. You know, if you have multi-layer perceptrons, it's hard to explain. And in many situations like healthcare, neural networks just have never really gone over well because you have to end up explaining the results to a physician. And if you're giving them a risk score, they need to understand exactly what went into that risk score so they can have a conversation with their client, their patients, and talk specifically about, okay, what do we do about this? If it's hidden layers, it's hard to do. So I think more than anything, my training in cognitive and social psychology trained me to be a better thinker. I would also say that it helped me develop appreciation and an awareness for things like behavioral economics and cognitive biases, which affect our ability to actually use data properly without that just core fundamental problem-solving skill set.
Interesting. So in your book, you do talk about design thinking as having an important role in the analytics lifecycle. What do you mean by that? What is design thinking? When I think of design thinking, I think of somebody in the turtleneck designing the next iPhone.
That's right. That's right. Black turtleneck.
Right, black turtleneck. Are there any other kinds?
Yeah. So design thinking is really a way to turn product or service design on its head by focusing on what does the customer really need. The example I give is we were working with a customer on the IT side of the house, and they were really struggling with understanding the business requirements, and they kept going back to this happened to be a heart and cardiovascular service line in a hospital, and they kept saying, well, we want to be able to use data more effectively in our processes, and IT would say, well, what are your requirements? And this conversation just happened, back and forth. And they were speaking two languages. And what design thinking does is helps us understand from an empathy perspective. We start with empathy and we says, we say, what is it that you're trying to achieve? What does good look like? How will we measure it? What's the best thing that could happen? And then think about how they'll use it. Imagine how many analytic products would have not failed had we actually spent the time and energy going to the business and say, well, walk me through your decision-making cycle. What do you do when you see this number? Where do you go? Oh, I usually go down and talk to Pamela, or I usually do X. Right. And if we were to have those conversations, and that starts with understanding a day in the life of the people who have the problem, that use the data, that create the data, and turn that around. So in that customer example, what we were able to do is actually bring both sides of the demand side, supply side, IT business together, but not talking about user requirements and design specifications. We talked about it in terms of what does the day in the life of a patient experience look like? And then you mentioned a word I like to use a lot, which is this data exhaust. So let's look at what data gets generated, gets input, or is a byproduct of these processes. And at the end of those exercises, where we took 3 or 4 personas and we looked at what are those use cases, then we sort of did this mapping of the digital exhaust that comes out of this. And that defined the data needs for this organization, because they said, well, I need to know, if I'm talking with this patient, I'm going to need to know X, Y, and Z. And all of those were captured not as in what fields, what requirements, and how often do you do it, but more from a user experience, a journey that was really helpful in articulating how do you actually gather this information in a collaborative way. So I throw that as an example of what design thinking might look like. We also apply design thinking to products, right? So if someone's going to see a number on a dashboard, what are they going to do with it? How do we design it in a way that they can actually be consumed usefully? But we also can think of that as, how do people consume our services in analytics? So how do they make a request? Who do they make a request to? How do they indicate the severity or the importance or the urgency? How do they get status and updates on that request? And if we design our services with that same design thinking principles in mind, then I think we'll be much better off. And so I outlined some ideas in the book about how to do that.
Interesting. So when someone, I imagine, as a C-level executive, they hear the word empathy.
Yeah.
Do their eyes roll, or because I mean, it sounds touchy-feely, but I get it. But how do you get others to get it?
Typically, I don't use the word empathy when I'm talking to us.
Okay.
So, here's the value of doing something differently, because what we've tried is not working very well. We've seen 40% of our projects fail time and over again. And so let's try something different that helps bring people closer together, so that we can bridge the gap between the language that often exists. And we've got some methodologies to do that. That's how the conversation would happen with an executive, in my opinion.
Interesting. And where do you see, particularly in the medical field, where do you see the role of IoT? Because one of the things that I actually was with the same child, he hit his head, and I was reading something about data leakage, and it's particularly a problem in the medical space, where they only take your vitals, but so many times an hour. Now, there's very practical reasons why that is, but it turns out that there's some cutting edge research now where they're implying that an infection can be detected 24 hours before there's any clinical signs, because if they monitor slight fluctuations in heart rate, et cetera, et cetera, et cetera.
That's right.
How do you see as IoT kind of filling in the gaps where obviously you can't have a nurse attend to a particular person taking their pulse, so often? How do you see IoT as playing in this role and supplying more raw data to be processed into the analytics pipeline?
Yeah, I'm probably a little bit controversial in the sense that I think analytics embedded within devices is going to be the key. I don't think we are necessarily going to use dumb sensors to collect data and then throw it back across the wire to the cloud. Just not enough time and energy to do that. Right. A good example in IoT, as you mentioned in healthcare, there's a ton of telemetry data, probably on the order of what a driverless car might generate. There's an estimate from Intel that they'll generate about 4 terabytes of data per hour. And so
Wow.
what do you do with that? How do you collect it? What do you keep? What do you throw away? And I think we're going to continue to see this focus on data management becoming more important in dealing with all of those things. We learned a long time ago that devices are pretty good at doing very specialty things, right? For example, the credit card swipe machine that many of us use will authenticate. We developed a neural network for a credit card company years ago that was actually embedded within that device on a firmware chip. And so the idea is that if I can make decisions at the point that they need to be made, think of your home. When I come home, I'm going to automatically understand your patterns. And if I see something that's anomalous, I may report that as an alert to my security company. I may change the temperature if I understand your patterns, things like that. But it's not being collected in aggregate, throwing back to the mothership and being collected in some massive data warehouse or data lake. I think the mindset for how we use these devices, embed analytics near the time where decisions can and should be made are going to be the key in all of this.
Right, because 4 terabyte an hour and multiplied times, just if you're driving in your car or imagine that 4 terabyte an hour for every car you see potentially. And I know 5G has some impressive bandwidth, but not, I mean, there's, that's just too much even for that.
That's right. Well, think about the rich convenience store in the United States. They have video running, and they've opted in most cases to say, look, we're going to put it on a 72-hour loop. Anything that's older than 72 hours, if the police haven't shown up, too late. We're not going to collect that. I think you talked earlier about some of the privacy concerns and data collection concerns. I think this is going to be one of those areas where if a murder was perpetrated, did Alexa hear it, and do we have the data to go back? So these are all interesting challenges for us.
It's a good time to be a lawyer in this space, huh?
Or a data guy, right?
Or a data guy or gal. So tell me more about the book. Where can I buy it? Is it on Amazon? Is it is there a website?
It is. So there's a website, my own website called the Analytics Lifecycle Toolkit.com. But you can buy it. There's an example chapter on my website if you want to learn more about some of the 5 best practice areas and how design thinking can inform that. That chapter is free on my website. And then if you go to Amazon.com and just search for Analytics Lifecycle Toolkit, you can buy it today.
Cool. And will there be an audio version for Audible listeners?
If there's a demand, I think that's a good idea. I couldn't imagine how to put someone to sleep more quickly. There is a Kindle version, though.
There is a Kindle version. No, well, that's good. So if we have any questions from our audience, which I don't see that we do, I want to thank you for your time. And I'm really excited to read this book. In fact, I'm probably going to hit up Amazon right now and get my copy, and I'll be on the lookout, see if it shows up in my Audible queue.
Sounds good. If you're ever in Carolina, I'll be happy to sign it for you.
Awesome. Thank you very much.
All right.